Welcome students to session number 32. Today we are going to see few numericals of textual exercises. The numericals today that we are going to discuss are based on the concept of number 1, that is relative velocity, and number 2, the concept of speed. Clear? Now tell me what exactly relative velocity means. Relative velocity means is nothing but the comparison of velocity of two objects. Yes or no? The word relative comes only if there is comparison between two objects, else the word relative never comes. I have already discussed one example before in which I have discussed relative density. Yes or no? Hope everybody knows the example first of the exercise, where I have told that if relative words is compared, then the density of the following object is compared with density of water. If density of the object is compared with density of the water, then we can say that this density is nothing but what kind of density? Relative density. Relative to compare with others. In simple language. Here we'll say example number 3.5. Example 3.5 in the exercise. A rocket is moving upwards. A rocket is moving upwards with a speed of 500 kilometers per hour. Here the rocket is moving upwards with the speed of v1, that is how much? 500 kilometer per hour. We know that this is your earth, or you can say surface of earth, where observer is there, where observer is observing this rocket, where this observer is observing the rocket. You will able to notice one thing over here, that if the rocket is moving upwards, then the ejected material that is being thrown out of the rocket while it moving, means the gas is being burnt in order to move the rocket upwards. This combustible products, or you can say ejected products, move at a speed of 1500 kilometer per hour. How much? 1500 kilometer per hour. With respect to, they have given with respect to object, with respect to rocket. Till this clear? The rocket is moving at a speed of 500 km per hour. The objects that are being ejected out from the rockets are being compared with the speed of rockets, and it is given 1500 km per hour. Now remember one thing over here. They have given V21, that is 1500 km per hour. Now think over here, if I take the movement of rocket to be plus, that is upward motion is considered to be plus, upward motion considered to be plus, then this motion where objects are being ejected downwards are considered to be what? Minus. Combustion objects ejected out is considered to be what? Minus. Till this clear? So here you will able to notice that the relative speed of the objects that are combusted out or that are ejected out with respect to the speed of the rocket is considered to be minus. Why? The ejected products are in opposite direction of motion of rocket. Why I have written this? Because rocket is moving upwards and objects that are ejected are moving downwards. Yes or no? Clear? Fine. So I am going to get V21, that is equal to V2 minus V1. V21 already have the ready with me, that is minus 1500. What is V2 with us? I don't have, because I need to determine the velocity of object 2 with respect to the observer, means I need to calculate V2. So V2 minus, what is this V1? Speed of the rocket upwards. Yes or no? That is how much we do have, that is 500. So V2, that is equal to minus 1500 plus 500, because this I am sending over here. So V2 I am going to get minus 1000 kilometer per hour. Till this clear? Hope it is clear. But here you will able to notice one thing. Why minus is coming over here? Can anybody tell me why minus is coming over here? The negative sign over here represents that the direction of the combustible objects that are ejected out from the rocket is opposite to that of motion of rocket. Very good. So here negative sign represents, the object, the materials, you can say, ejected out. The materials ejected out are in opposite direction, to the direction of rocket. Clear? The direction of rocket is upwards. Ejected material is downwards. They are opposites. Yes or no? So this is minus. Now you can say they are asking what? Speed of letter with respect to ground. With respect to ground means they are asking with observer. With observer you don't have to show this minus. So you can write what? 1000 km per hour. Is this clear? Perfectly. This is the final answer. Hope it is perfectly cleared. Fine. The next example we are going to see today, that is example number 3.4. In example 3.4, remember one thing. A drunkard is moving along a narrow lane. Drunkard means the person who has drunk the alcohol is moving on a narrow lane. You know the movement of a drunkard person, yes? It moves few steps forward and then it moves few steps backward. Yes or no? So you can say that a drunkard is moving on a drunkard is moving on a narrow lane. They are given 5 steps, it's move forward. 5 steps it moves forward and 3 steps it moves backward. Forward and 3 steps it moves backward. Provided steps are of 1 meter and time 1 second. Here you will able to notice they have mentioned that the drunkard is moving on a straight lane in which it moves 5 steps forward and 3 steps backward simultaneously. The length of the step is 1 meter and time taken to cover one step is 1 second. Now you have to think over here that such type of numericals can be solved by 2 methods. That is one analytical method and second is graphical method. Clear? So I am going to give you the solution with analytical method and I am going to give you the table format for the graphical method too. You have to just plot the point in order to get the XT graph for the same. They are asking how much time will this drunkard take? Will this drunkard takes in order to fall in a pit situated at 13 meters away from start point. As soon as he starts his journey, from that starting point, the pit is situated 13 meters away. How many meters? 3 meters. Till this clear? Now you have to be able to notice, see what happens over there. I'll draw with the figure and I'll explain you very nicely. 1, 2, 3, 4, 5 steps are being forwarded. 5 steps. So how many seconds? 5 seconds. 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. Yes or no? So 5 steps, 5 seconds. At the simultaneously, it is moving back 3 steps. 1, 2, 3. So down how many steps? 3 steps. How many seconds? 3 seconds. Till this clear? Moving upwards 5 seconds. Moving downwards 3 seconds again back. So 5 seconds, 3 seconds means total time. Total time is how much? 8 seconds. Till this clear? Total time is 8 seconds in one lap. 5 steps forward, 3 steps backward. Now you will be able to check the distance. Distance traversed. Distance traversed, you will be able to notice that it is moving 5 steps forward and 3 steps backward. So 5 plus minus 3 means in each lap is covering how much distance? 2 meters only. Because it's moving 5 steps and coming back 3 steps. If I move forward and come back, you will be able to notice what? The distance covered is very less. That is 2 meters over here. So I can say that for 8 seconds, he is covering only 2 meters distance. Till this clear? Remember one thing, for this 8 seconds, if the distance covered is 2 meters, for 8 seconds if distance covered is 2 meters, you will able to notice that for the next 8 seconds, the distance will be how much? 4 meters? Yes or no? For next 8 seconds, the distance will be how much? 6 meters? For the next 8 seconds, the distance will be how much? 8 meters? Yes or no? Yes or no? First 8 seconds 2 meters, second 8 seconds 4 meters, second 8 seconds 6 meters, second 8 seconds 8 meters. Means able to notice over here 4 8 32 seconds will be covered. 32 seconds will happen if you will cover only 8 meter distance. 8 meter distance, 32 seconds. Till this clear? Now remember one thing. 32 meter is being covered, 32 seconds is being taken in order to cover only 8 meters. Now pit is how many meters away? Can you tell me? Pit is how many meters away from the start point? Very good. The answer is 13 meters. Clear? So the pit is 13 meters away from the starting point. So you will able to notice that how many you will add over here to make 13. I am sure that you will add 5 to get to how much? 13 meters. Clear? Why I have stopped at this 8 meters? Because after 8 meters again he will move 5 steps forward. So 8 plus 5 is how much? 13. As soon as he moves 5 meters, 5 steps forward means it's covering 5 meters away. You will able to notice that the addition 8 plus 5 is 13 meters. Means he will fall down into the pit. He is not going to move backwards. He is not going to get the chance to move backward. Till this clear? So as soon as after 8 meters he moves 5 steps forward, he falls into the pit. So for 1 step was 1 second. So for 5 steps it's what? How much? 5 seconds. For 1 step, how many seconds? 1 second. So 5 steps, 5 seconds. So 32 plus 5, your answer is how much? 37 seconds. 37 seconds is your answer in order to cover 13 meters and to fall into the pit. Is this clear? 100% clear? Any doubt? No doubt. Now I'll show you the graphical table for which how in order to calculate the values. Let us make the graphical table. For the graphical table, I'll tell you how to move. This is your X and this is your T. If you are starting with 0, 0, 0, start point, then you're able to notice what? 0, 0. Then first 5 meters means 5 seconds. So 5 meters. Then 3 seconds means 8 time. Yes or no? Times in seconds and distance in meters. 8 seconds, how many distance? 2 meters. Yes or no? How much distance? That is 2 meters. Next we'll add again 5 to 8. 8 seconds plus again 5 seconds. That is how much? 13 seconds. Distance 2 plus 5, that is 7. Yes or no? 2 plus 5 is how much? 7. Till this clear? Next 13 plus 5, that is 13 plus, see this is 5 steps, this is 3 steps, again 5 steps, now again 3 steps. 13 plus 3 is how much? 16. And 3 will be reduced from here. So it will be what? 4 meters. Check. 8 plus 8 is 16 and distance covered is how much? 4 meters. Is this clear? Now 3 again 5 means how much seconds? 21. Your distance will be 4 plus 5, that is 9. Again if you add 3, that is 24. Yes or no? But 9 minus 3 you have to subtract because it is moving 3 steps backwards. So answer is how much? 6. Check. 8 3 is 24 seconds and your distance covered is how much? 6 meters. Perfect. Fine. Now 24 seconds you got. Next again you add 5. That is how much? 29 seconds. You will able to notice one thing. 6 plus 5. That is how much? Your 11 meters is the distance covered. Moving ahead, I have to reach till 13 meters. X in meters and T in seconds. Till this clear? After 29, again 3. So after 29, 3 is how much? 32. 11. You will able to do what? 5. That is how much? 16 meters. Yes or no? Or 8 meters. Check. This is plus 5. Clear? Then you have subtracted 3 plus 5. minus 3 plus 5 minus 3 plus 5. Now again minus 3. 11 minus 3 is how much? 8. Yes or no? 8. Check. 4 is the 32. 4 is the 32. How much distance? 8 meters. I am very perfectly going for the graphical method. Till this clear? Fine. So 30 to 8. Now I have to check again. 5. That is how much? 37 seconds. Plus 5. So again over here will be plus 5. So 8 plus 5 is how much? 13 meters. I have to stop over here. 13 meters. Pit is located away. So time taken is how much? 37 seconds. This is a very fast technique that you can use for the JEE NEET cases. Clear? Rather to solve this, it's better you go for this graphical method. You are able to get the particular instant how much distance is being covered particular instant. Is this clear? Okay. Now we are going to move to the example 3.3, in which they have told that a lady is moving from her home to office. From her home to office, which is situated at a distance of 2.5 kilometers and which is very straight to its home. The journey is started at 9 a.m. The journey started at 9 a.m. and the lady to the office, it stays up to how much time? 5 p.m. Till this clear? After that it return back to home. Back to home. Till this clear? Here in the data they have given that the lady moves from home to office, which is situated 2.5 kilometers by walking. By walking. So we'll case 1 will say journey from home to office. Home to office. Clear? We know that the distance from where home is located, office is located from the home. Can you tell me the distance from home to office? How much? 2.5. Very good. So distance is 2.5 kilometers. Till this clear? Speed. It moves with a speed of. From home to office the speed is 5 kilometers per hour. And from office to home the speed is 25 kilometers per hour. Because it is moving by rickshaw, auto. Clear? The speed of provided over here, that is 5 kilometers per hour. Is this clear? Now we do have distance with us. Now we do have time with us or speed with us. If they are having 3 parameters, in order to determine any one, we need to know rest 2. Yes or no? So here we do have distance with us, speed with us. So we can calculate time taken to reach office. Time taken to reach office. Till this clear? Time taken to reach office is equal to what? Speed is equal to what? Distance upon time. So time is equal to distance upon speed. Very good. Distance upon speed. What is distance over here? Distance is nothing but what? 2.5. Excellent. Distance is 2.5. Speed is 5 kilometers per hour. So 5 is it will be 0.5. 0.5 means half hour. Half hour is nothing but how much? 30 minutes. Half hour is nothing but what? 30 minutes. So it started its journey at what time? 9 a.m. Yes or no? Started its journey at 9 a.m. So reached to office how much time? 30 minutes. So at office, what would be the time? 9 hours 30 minutes. So it will be 9:30 a.m. Till this clear? This is at home. This is at office. She will start its journey from 9 a.m. She is going to reach to the office at 9:30 a.m. respectively. Till this clear? Fine, it is clear. Now moving to the next, that is, next we do have with us, that is second, journey from home, journey from office to home. Office to home means she is returning back to home from office. She is returning back from office to home. Now remember, again we do have speed with us. Speed is given, that is 25 kilometers per hour. Very good. What is distance? From home to office is 2.5 kilometers. So from office to home is again 2.5 kilometers. Yes or no? So again, your distance is nothing but how much? 2.5 kilometers. So again, time taken to reach home from office from office, that is equal to distance upon speed. Yes or no? Distance upon speed. What is distance over here? 2.5 kilometers. Very good. 2.5 kilometers. What is speed? 25 kilometers per hour. So your answer is how much? 0.1, that is 1 by 10. 0.1, that is nothing but 1 by 10 hours. 1 hour. How many minutes? 1 hour. How many minutes? 60 minutes. So I'll multiply by 60. 0, 0 cut. My answer is how much? 6 minutes. My answer is 6 minutes. So she started her journey from office, that is 5 p.m. It takes 6 minutes to reach its home. So the answer is how much? 5-6 p.m. 5-6 p.m. That is back to home. And here she was at office. Till this clear perfectly? Any doubt? No doubt. It started its journey at 5 and ended at 5-6. Now if somebody asks you to plot xt graph for the same, how we are going to plot xt graph? Very simple. X, that is in meters, t, that is in hours. Till this clear? We'll consider this to be home. Home, yes or no? And the timing will start with is 9 a.m. Clear? Then 10, then 11, 12, 1, 2, 3, 4, 5 and 6. Why I have taken upper boundary to be 9? Because it started its journey from 9 and ended at 5-6. Yes or no? So I have to take till 6 hours. Till this clear? Distance 1, 2, 3. Clear? You'll remember one thing, that office is situated at 2.5. You have to mark this point is 2.5 kilometer. And where it is nothing but what? Office. Yes or no? Office. You can put a dotted line over here in order to get the level of the office from home. Fine. It started its journey from 9, reached office at 9:30. Reached office at 9:30. So I can mark this point as what? 9:30 a.m. And I can mark this point as what? 5-6 p.m. Yes or no? Where she is returning home. This point is nothing but what? 9:30 a.m. and this point is nothing but 5-6 p.m. where she reaches home back from office. So I can state that over here. It starts its journey from 9 and it reaches the office at 9:30. She stays up to 5 in the office, 5. Then after 5, she starts returning back to the home and she reaches the home at 5-6. So this is the nature of your graph, or you can say figure xt graph for the journey. Xt graph for the journey. What do you mean by xt over here? X. What is x? Very good. Position. What is t? Time. Perfect. We'll see few numericals more into the next session. Till then, thank you.